Hello everyone. So this is the section B MSQ solutions question. This is from which question? Question 31 to 40. It is 2 marks each and there is no negative marking. Okay, so what I would suggest is whenever you get an MSQ section, you can solve this at the last. Okay, and what you can do is you have to mark all the options. Okay, even if you are not sure, do an intelligent guess and solve all the 10 questions because there is no negative marking. So even if it is wrong, you will not get any negative markings. The first question, which of the following molecules are anti-aromatic? Let us first see what are the conditions for a molecule to be anti-aromatic. Okay, for a molecule to be anti-aromatic, it should be cyclic, it should be planar, it should have conjugation, and it should have 4 pi electrons. Okay, now let us see all the options. First one is incorrect. Okay, you might see that there are 4 to the 8 pi electrons. So it follows 4 pi electron rule. If I put n is equal to 2, I will get 8, but still it is not correct. Why? Because of the electronic repulsion, this molecule is not planar. It is a molecule like this. It is a tub-shaped molecule. Okay, so it is a non-planar. Okay, the non-planar compounds are what? They are non-aromatic. Okay, non-aromatic. So if you have marked option A, that will be incorrect. Option B, 2, 4, 6, 8. So it follows 4 pi electron rule. 4 pi. If I put n is equal to 2, I will get 8 pi electrons. And is it planar? Yes, it is planar. So B is correct. C, if we see here, for C, what I can do is, this is more electronegative, so we can break this bond like this. I will get O minus. We have to check only this ring. Okay, here we will get positive charge and pi bond. So here there are how many pi electrons? There is only 2 pi electrons. 2 pi electrons. So 4n plus 2, if I put n is equal to 0, I will get what? I will get 2 pi electrons. So this is what? This is an aromatic compound. Okay, since it is aromatic compound, this is also incorrect. D option, what I can do, I can break this double bond on this side. What I will get, pi bond, negative charge, and here there will be a positive charge and pi bond. Here also, if you see, first let us see this ring. This is same as this. This is aromatic. Okay, 2 pi electrons, it is aromatic. Here if we see 2 plus 2, 4 plus 2, 6 pi electrons. If I put 4n plus 2, if I put n is equal to 1, 4 ones are 4 plus 2 is 6 pi electrons. So this is also what? This is also aromatic. Okay, so what was the purpose of this question is option D is also incorrect. Only option B is correct. Now you would say it is an MSQ question, then why only one option is correct? So in MSQ also they write one or more than one. Okay, so there is a possibility that in MSQ section also there is only one correct answer. Either one or more than one can be correct. So the point was that in MSQ section also there can be a question where only one option is correct. So here what is the correct answer? Correct answer for this question 31 is only B. Let us see next question. Which of the following statements are true? Okay, always mark this very important. Whether true or false is asked. Which are true for this molecule? Okay, so if I draw the structure, this is what? This is carbon dioxide. It is linear geometry, 180 degrees the bond angle. Hybridization is what? It is sp. Okay, so here if we see, this is a center of symmetry at the carbon. If I draw this point, on the right hand side if I go, there is oxygen. On the left hand side also there is oxygen. So center of symmetry is present. According to the rule of mutual exclusion, what does it say? That the molecule where there is center of symmetry is present, Okay, that is going to be, okay, first let us see whether it is IR active or not. So for IR, what is the conditions? Only homodiatomic molecules. Okay, only homodiatomic molecules like Cl2, F2, H2, O2, Br2. Okay, these are what? These are IR inactive. Okay, rest all other. Okay, all except homodiatomic molecules are what? They are IR active. Okay, this is the condition for finding out whether a molecule is IR active or inactive. So CO2, is this a homodiatomic molecule? No. It is a triatomic molecule. It is a heterotriatomic molecule. Okay, there is two, one is carbon atom and two oxygen are present. Okay, so it is IR active? Yes. And what does this rule of mutual exclusion principle says? If a molecule is IR active, then it will be Raman inactive. And if the molecule is IR inactive, then the molecule is going to be, okay, IR is inactive, Raman it will become active. Yeah, opposite. If IR is active, Raman inactive, IR is inactive, Raman will be active. Okay, Raman is nothing but which waves we use in that? We use microwaves. Okay, so IR active, so it is going to be microwave inactive. IR active, microwave inactive. If you have left the question at option A and B, then your answer is going to be wrong because it is very important. You have to check all the options. See, if it is microwave inactive, last option is incorrect. Okay, it cannot be both active and inactive. Rotational inactive. Now, what is the condition for rotational? Okay, if you want a molecule to be rotationally active, there should be change in dipole moment. Change in dipole moment. That means the dipole moment should not be equal to 0. But in CO2, if we see, this is one dipole moment, this is another dipole moment, overall mu is equal to 0. So it is going to be microwave inactive. So option C is also correct. Okay, so what are the correct answers for this question? It is going to be A, comma, B, comma, C. Now let us see next one. Which of the following are isolable to FeCO4? Okay, what is the meaning of isolable? We are trying to find a relation between the complex and the inorganic fragments. Okay, 14 electron complex is isolable with 4, 15 with 5, 16 with 6, 17 with 7, and 18 with 8. So let us first count the total valence electron in FeCO4. Fe, it is how many total valence electron? 8. Plus carbonyl, one carbonyl is 2, so 2 into 4 is what? It is 8. 8 plus 8 is 16. So what we have to do? We have to either find a 16 electron complex or a 6 electron fragment. Let us see one by one all the options. Sulfur. Sulfur has how many valence electrons? It has 6 valence electrons, right? Ns2, Np4. So option A is correct. B, cobalt, Co, Cp. Okay, Cp, if the hapticity is not mentioned, you consider it as 5. Cobalt, 7 plus 2, 9. Plus carbonyl is 2 plus 5. 9 plus 2, 11 plus 5 is 16. So this is also correct. Third one, CH minus. This is carbon is 4 valence electron, right? Ns2, Np2, 4 valence electron plus hydrogen is 1 plus negative charge means you have to add one more electron. 4 plus 1, 5 plus 1, 6. C is also correct. Now let us see last option, option D, CH3 plus. Okay, here also carbon is 4 plus 3 hydrogen and negative charge means you will remove one electron. 4 plus 3, 7 minus 1 is 6. So D is also correct. So which are the correct options? A, B, C and D all are correct. Okay, A comma B comma C comma D. Next one, select the options that are incorrectly matched. Okay, you have to select the incorrect statements. First one, hemierythrin is used for oxygen transport. Okay, before that, this is from which chapter? It is from bioinorganic chemistry. Okay, first, what is given is the enzyme. Next, what is given is their function. Okay, what is their use or what is their function? First option, hemierythrin is used for oxygen transport. This is a true statement. So this is not going to be the correct answer. Coenzyme B12 is used for oxidation? No, it is not used for oxidation. It is used for methylation. What is the meaning of methylation? Addition of a CH3 group is called as methylation. So this is incorrect. So B is correct option. Carbonic anhydrase is used for hydrolysis of peptide bonds. This is not the true answer. Which is used for hydrolysis of peptide bonds? It is called as carboxypeptidase. Okay, how you can remember this? In the word itself, peptide comes. So peptide bond will be broken by carboxypeptidase. Okay. The C option is the incorrect statement. So what is the role of carbonic anhydrase? Okay, what is the role of carbonic anhydrase? It does hydrolysis of CO2. Hydrolysis of CO2. What we will get? CO2 plus H2O will give what? It will give H2CO3, carbonic acid is formed. Okay, so this is an incorrect statement. Okay, so this is also going to be the correct answer. Last one is amine oxidase. It is used for oxidation of amine to nitro. No, it is used for oxidation of amine to aldehydic group. Okay, so this is also a incorrect statement. So D is also correct. So which are the correct answers? Correct answer is B, comma C, comma D. 35. Which of the following are correct for ideal solution? Okay, I'll tell you what is the correct statement for an ideal solution. Ideal solution, you can remember all the delta, okay, delta of all the properties of mixing is equal to 0 except delta G mixing and delta S mixing. Just like we do in thermodynamics, what should be the delta G value? Delta G value should be negative, which means it should be less than 0. And delta S of mixing should be what? It should be positive, that is greater than 0. So let us see, is this option available? Delta G is less than 0, correct. Delta S is greater than 0, that is also correct. And I told all other properties are what? 0. So delta H is 0, correct. Delta V is 0, that is also correct. So the correct answers here are A, B, C and D. Next one, which of the following compounds is show 4 1H NMR signals? Okay, and IUPAC names are given, so it is very important that you know the IUPAC names. First one, 2-chlorobutane, CH3, CH, H, CH3. Why I've drawn like that, I will tell you. Suppose you have marked, let's count normally, it is 1, this will be 2, this 2 will be 3, and this will be 4. If you have marked option A, that is going to be incorrect. Why? Because this carbon, if you see, it is a chiral carbon. Okay, Cl, methyl, hydrogen, and this ethyl group. So if it is a chiral carbon, remember that these two hydrogens will be what? They are going to be enantiotopic. Sorry, one chiral carbon is already present, so both these are what? They are diastereotopic protons. Okay, diastereotopic protons. So both these protons, they are what? They are going to give you, they are going to give different peaks. Okay, so the number of peak, if we count again, this will be 1, this will be 2, this hydrogen will give separate 3, this hydrogen will give 4, and this will be 5. So total how many signals are present? 5. So option A is incorrect. Diethyl succinate. You must know the structure of diethyl succinate. CH2, C double bond O, O, diethyl means CH2, CH3. Okay, CH2, C double bond O, O, CH2, CH3. Okay, I had given you, I had made a video of named all such, oh my such good apple pie, where I had given you the trick to remember this succinic acid. Okay, you can watch that video. I will provide the link in the description. Okay, if you know what is succinic acid, then it is simple. Diethyl means you have to add CH2, CH3. Here also you will add CH2, CH3. Now, if you see, there is this plane of symmetry that is passing. You can see both are what? Both are mirror images of each other. So this is A, this will be A, this is B, this will be B, and this is going to be C. So total there are three signals. Three signals means this option is incorrect. Now ethyl ethoxyacetic acid. Okay, let me erase this. Okay, so option A is incorrect, option B is incorrect. C, ethoxyacetic acid. What is acetic acid? Draw that first. CH3, C double bond O, OH. Okay, ethoxy means remove one hydrogen and add ethoxy. Ethoxy means CH3, CH2. This is ethoxy. Now count the signals. 1, 2, 3, and 4. So here 4 signals are present. The option is correct. N-propyl formate. Formate means formic acid. Draw formic acid first. Okay, formate means here ester group is present. N-propyl. N-propyl means CH2, CH2, CH3. This is N. N means normal chain. Normal means straight chain. Okay, now we can count. 1, 2, 3, and this proton 4. So here also 4 signals are present. So option D is correct. Which are the correct answers? Correct answer for this is C, comma D. 37. Select the correct statement during a beta decay. Suppose if I take this, atomic mass number is A and number is Z. Beta decay means minus. What is beta? Beta is nothing but an electron. Beta particle is electron. Electron has zero mass and negative charge. So you can see minus into minus will become plus. So atomic mass number remains the same. Atomic number will become Z plus 1. So it increases by 1 unit. Which increases? Atomic mass will not increase, atomic number will increase. So this is not correct. During an alpha decay and positron emission. Okay, let us see alpha decay now. What is alpha particle? It is a helium nuclei. Helium nuclei atomic mass is 4, number is 2. Okay, this is an alpha particle. Okay, so atomic mass decreased by 4, atomic number decreased by 2. So option B is correct, that atomic mass number decreased by 4 unit. This is also correct, atomic number decreased by 2 unit. Now we have to see positron. What is a positron? Let us see that. Positron is same as electron, only the charge is plus 1. Okay, mass is 0. This is what? This is a positron. You can remember this. Charge is opposite to that of electron plus 1. So minus into plus is minus 1. So Z minus 1. A plus 0 is A. So atomic mass number remains same and atomic number decreased by 1 unit. So this is also a correct statement. Correct answers here are what? They are B, C, D. 38. Which of the following reaction yield benzaldehyde as a product? You must know what is benzaldehyde. Benzene, C double bond O H. Okay, first one is SOCl2 quinoline. This is a substitution reaction. C double bond O OH. Okay, let me write here again. C double bond O OH. Okay, I add SOCl2. There will be substitution reaction. What I will get? I will get benzoyl chloride, COCl. Next is H2PD BaSO4. This is a reducing agent. So what will happen? This will reduce this to Cl will be reduced to aldehyde. Okay, and this is benzaldehyde. So option A is correct. Okay, now let us see next one. CrO3H2SO4. Okay, CrO3H2SO4. This is a strong oxidizing agent. This will convert this benzylic primary alcohol to what? It will convert primary alcohol to carboxylic acid. This is benzoic acid. So this is not correct. NaBH4 does not reduce ester. Okay, it will not react with ester. So this is also incorrect. Option D. What happens in this first reagent? Let us see. Okay, what will happen? Two hydrogen of this CH3 group is replaced by ester group. OC double bond OCH3. This is the first step. Next step, when I do hydrolysis, what will happen? This will break OH, OH. Okay, 2 molecules of acetic acid is released. Okay, here there are 2 OH that is formed. OH, OH. 2 hydroxyl group at 1 carbon is not stable. So what will happen when we heat them? This will be a release. There will be water molecule that will be released. What we will get? Carbon. Hydrogen is already there here. This hydrogen you can see here, and C double bond O. This is what? This is also benzaldehyde. So the correct answers are option A, comma D. 39. Which of the following conversion can be carried out by set of reagent and is the only product? This is very, very important that only this product is formed. There are no side products. Okay, this is very, very important. First option. Okay, first step is this is which reaction? Anhydrous AlCl3 and alkyl chloride. This is Friedel-Crafts alkylation. First step is you will remove this Cl minus. I will get a carbocation, that is a primary carbocation, which is less stable. So what we can do? We can do 1,2 hydride shift. We will get a secondary carbocation. So this is going to react with what? This is going to react with benzene. And the major product here will be what? It will be isopropyl benzene. This is going to be the major product. Okay, this will attack this carbocation. Okay, so option A is what? A is incorrect. Okay, this will also be formed, but that will be the minor product. Why? Because the primary carbocation, this primary carbocation is what? It is less stable. Okay, this will be formed, but this is going to be the major product. Let us see the next one. B. Okay, first step is I will remove this Cl. What I will get? I will get CH3, CH2, C double bond O. Sorry, one more carbon. CH3, CH2, CH2, C double bond O plus. Okay, benzene is going to react with this. What we will get? We will get C double bond O, CH2, CH2, CH3. Next step is what? Zinc, amalgam and HCl. This is which reaction? This is Chemazon reduction. Chemazon reduction, what it does? It reduces the aldehyde or it reduces ketones to CH2, alkane. So this is which product? If you draw in bond line 1, 2, 3, 4. 4 carbons are formed. We want only 1, 2 and 3 carbon. B is also not correct. C, okay, C if we see, option C, first is Cl2 and H nu. So benzene, okay, in presence of Cl2 and H nu, it will form what? It will form chlorobenzene. Okay, chlorobenzene then reacts with 2 moles of Na and another is this one, Cl. Okay, so 2 moles of NaCl will be released, and what we will get? We will get this desired product. And if you have marked the option C, that is going to be incorrect. Why? Because in the question it is asked only this product is formed. We know this is which reaction? This is called as Wood's reaction. In Wood's reaction, self products are also formed. Self coupled products are also formed. So we will get other byproducts as well, like biphenyl, and this is a 3 carbon. So we will get 1, 2, 3, 4, 5, 6. Okay. We will also get hexane. So these two byproducts are also formed. So that is why C is not correct. D, if we see, okay, D, if we see, first step is going to be removal of this Cl group. What I will get? CH3, CH2, C double bond O plus. Okay, this will attack, benzene ring will attack here. What we will get? We will get C double bond O, CH2, CH3. Next is same zinc amalgam and HCl. This will be reduced. We will get CH2. Okay, so this is the correct answer. 1, 2, 3 carbon. Correct answer here also you can see there is only one option that is correct. Option D. Last option of the MSQ section. Which of the following are achiral? Achiral. We have to find out which are achiral, or we can say optically inactive. Okay, first one. This is sp3 hybridized carbon. Okay, if you have passed a plane and you have marked option A, that is going to be incorrect. Why? Because if I draw the actual structure of this is, okay, two bonds are in plane and the remaining two bonds of the ring are going to be what? They are going to be in a perpendicular plane like allenes. Okay, so this is chiral. This is not a chiral. B option, two pi bonds. So is it going to be chiral? No. Here you can see two methyl groups are same. So here plane of symmetry will be passing. Plane of symmetry is present. So this is what? This is achiral. If it is achiral, this is the correct answer. C option, if we see, C option, if you have seen that all the four groups are different, and if you have marked that this is a chiral compound, then that is going to be incorrect. Why? Because whenever you have to remember, whenever odd number of double bonds are present, okay, odd numbers of double bonds are present, molecular plane is present in the system. Okay, this is which system? This is called as cumulines. We had already seen in the video. Cumulines 1, 2, and 3, right? 3 pi bond means it is odd number of pi bond. So molecular plane is present, so it is going to be achiral. C is also correct. D option, if you had seen this is a biphenyl and if you have thought that this is going to be chiral, then again it is wrong. Why? Because there is a condition that for heteroisomerism, okay, heteroisomerism or for biphenyl to show chirality, it should have a bulky groups. Okay, bulky groups at the ortho position. But you can see H and fluorine, they are all small groups. So this is going to be achiral. It will not be chiral. So D is also correct. So which are the correct answers? Correct answer is B, comma, C, comma, D. So here we have completed MSQ section. We will see the NAT section in the next video. Thank you.